Hi there. My name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying quadratic relations. In particular, this video will look at word problems that relate directly to the quadratic formula, but also have a lot of other applications and connections as well. And if you're using the black textbook from McGraw-Hill, we're going to look at word problems that start on page 300. So the first word problem is question number 6. It says the path of a soccer ball after it's kicked from a height of 0.5 meters above the ground is given by the equation. So let's emphasize the equation. There it is. So this equation is the path of a soccer ball being kicked in the air. H is height above the ground. D is horizontal distance, and they're both measured in meters. Now, this question has an A part and a B part, but before I even read what I'm supposed to do, I'm going to make sure that I understand clearly what this relationship is. So, it's a relationship between height above ground and distance horizontally. So, it's not X and Y, and in their place, where the X normally is distance horizontally, and H, height above ground. So what else do I know? Well, I know that it is a negative parabola, which means that the soccer ball is going to go up and come back down, which is good because that's typically how things act when you kick a ball into the air. They typically go up and come back down. I also know that the starting position of the soccer ball is 0.5 meters above the ground. And again, I know that because this equation is given to me in standard form. And when an equation is given in standard form, that c value is the y-intercept. And in this case, it's the h-intercept or the starting value because we're not going to worry about negative distance or negative height. So we know that it's 0.5 meters above the ground, and of course we knew that anyway because it's told us. But just in case, make sure you see that it's given to you in the equation. So very quickly, a quick sketch, and you either kind of do this mentally or on paper, is if we start at 0.5 meters above the ground, we're going to kick the ball up to some height, I don't know what it is, and then it's going to fall back to the ground. So that's roughly what I'm dealing with in this question. Now that I have an idea about what's happening, now I can actually look at question A and see what I'm supposed to do with this soccer ball. So because I'm probably going to reference it, I'm actually going to take group. I'm going to take a copy of that little diagram I made. So let's read part A. Again, there's the equation. It says, how far has a soccer ball traveled horizontally when it lands on the ground? So how far has it traveled when it lands on the ground? So let's again look at that diagram. So this question is saying or asking us, when it lands on the ground, that's right here. So when it lands on the ground, how far has it traveled? So in other words, find D. So how far has it traveled horizontally says find D. So that means I must know what H is. Oops. So this is the point I want to talk about, right? Because that's where it lands on the ground. What is the height? Well, you can see from this little diagram that the height must be 0. So this question, how far has a soccer ball traveled horizontally when it lands on the ground, is simply saying find D when H equals 0. So let's go ahead and do that math. So sorry, I just cleared that picture so we have space to do math. So we're going to find D when H equals 0. So substituting 0 in for H gives me this equation. So how am I going to solve for D? Well, it's a quadratic equation and it equals 0. That's good. So my choices are I could try factoring. Yeah, I don't like factoring when decimals are involved. That just seems funny. I could complete the square and isolate, but that's an awful lot of math. My third option, the one I'm going to go with, is I'm actually going to use the quadratic formula. So that means I have to identify what A, B, and C are, right? So here's ax squared plus bx plus c. And now I can use the quadratic formula. So x equals negative b, oops, plus or minus the square root of b squared minus 4ac all divided by 2a. And of course, if you're not one of my actual students, you probably maybe haven't seen this before, but that's how I think of formulas, as blanks where I substitute in. So again, it was negative b plus or minus the square root of b squared minus 4a times c all divided by 2a. So now I can start to do math. So for me, oops, x equals, I have negative 1 plus or minus, and in my calculator, I'm going to do this math. So your calculator should be able to handle that no problem. 1 squared minus bracket 4 times negative 0.1 times 0.5, close bracket, equals. So I have square root of 1.2, and that's divided by, and then I'll do this math, 2 times negative 0.1. So at this point, I'm going to split into two different answers. So one is going to be negative 1 plus root 1.2 divided by negative 0.2. And one is going to be x equals negative 1 minus root 1.2 over negative 0.2. So again, in your calculator, get two different answers. Let's see what we get. So why am I using decimals when a lot of times in class I emphasize fractions? A couple of reasons. For one thing, the question specifically gave us decimals in the equation. And if you're given decimals in an equation, you certainly don't want to then convert to fractions because whoever set up the question was already talking in the language of decimals. Um, the other reason why for sure decimals are a good idea is it's a word problem based on sort of real life applications. And in real life, you generally talk about decimals. So it's very rare, if I'm asking someone for directions and they were to answer, well, you go 14/3 of a block, I'm probably going to give them a funny look, and I love fractions. So for sure, if they give you decimals, you give decimals. And also, if it's a real life word problem, then you work in decimals. So let's see what happened. I used a quadratic formula, and I got these two answers. I got a negative 0.5. Now you'll notice I use x. Okay, so my teacher should probably have told me to use d because the equation is based on d, not x. Fine, there you go. Let's look back again at this diagram and interpret the math that we just did. So the math we did tells us that there are two places where the height is 0. One of them, apparently, is about here at negative 0.5 seconds. And the other one is over here at 10.5 seconds. Well, I like this one. This one makes sense. When I've seen soccer balls hang in the air for 10 seconds or so. This one doesn't make sense. So why did we get it? Well, the algebra that we just did has no idea that this parabola represents a soccer ball. So it doesn't know to ignore negatives, but it gives us both answers as if this was purely algebra. But we know that this answer of negative 0.5 is what we call inadmissible. Which means it's not wrong. The math is correct, but we cannot admit that answer as one of our solutions. So it's a good word. You should learn this word when you're doing word problems. The other answer of 10.5, that makes sense to me. So 10.5 seconds, nope, not seconds. Sorry, I reread the question. 10.5 meters horizontally is how far the ball traveled. So the distance from its starting point to where it hit the ground is 10.5 meters from where it started. Now, there's also a part B to this question, and it says find the horizontal distance when the soccer ball is at a height of 2.6 meters above the ground. Let's look at that diagram again. So find the horizontal distance. So that's saying find D when h equals, well, let's find out. Find the horizontal distance. So find D when the ball is here, when h equals 2.6. So visually, somewhere on its climb, presumably, the ball gets to 2.6 meters above the air. And it should get there twice, here and here, unless maybe it doesn't get there at all. The math will tell us. But we're going to assume that it does get to 2.6 meters. So we're going to let h equal 2.6 and solve for d. So we have to let h equal 2.6 and solve for d. Now, we cannot do any of the solve methods like factoring or using the formula if it doesn't equal 0. So the first step is to make this equation equal 0. And to do that, we're going to subtract 2.6 from both sides and then collect like terms. Now I have a quadratic equation in standard form, ax squared plus bx plus c, and it equals 0. So now I need to solve for d. Oops. And again, to solve for d, you can try factoring. I'm not going to. You can complete the square. I'm not going to. Or you can use the formula. That's exactly what I'm going to do. So again, we have an a value of negative 0.1. We have a b value of 1. And we have a c value of negative 2.1. So subbing that in, x equals, well, again, learned from my mistakes last time, d equals negative b plus or minus the square root of b squared minus 4 times a times c, all of this divided by 2a. So now, again, it was negative b plus or minus the square root of b squared minus 4ac all over 2a. And you'll notice I say it out loud every time I write it. It's to encourage me to memorize it sooner. It helps me remember what the formula is if I say it out loud. It's kind of like practicing for a speech. If you can say it out loud to yourself, you can probably memorize it. So again, negative 1 is negative 1. Down here, that's negative 0.2. And in my calculator, I'll do this math, 1 squared minus 4 times negative 0.1 times, oops, negative 2.1. So this bracket becomes 0.16. And at this point, I'll split into two distinct answers. So D equals, let's see what I have, negative 1 plus root 0.16 over negative 0.2, or distance equals negative 1 minus 0.16 over negative 0.2. So over here, the square root of 0.16 is 0.4. So negative 1 plus 0.4. And this will be negative 1 minus 0.4. So two little quick things in your calculator. Negative 1 plus 0.4. So here I get 3. And here I get 7. So again, what does that, what do our answers mean? 3 and 7. So again, the horizontal distance is 3 and 7. So let's get that diagram back. I'm really big on diagrams. You guys know that. So what my math suggests to me is that the soccer ball reaches a height of 2.6 meters twice. Once when it has traveled 3 meters from its starting point, and again when it has traveled 7 meters from its starting point. So remember, we already calculated that this is 10.5 meters. So to me, my answer makes sense. If I had gotten negative numbers, I'd be confused. If I had gotten something bigger than 10.5, I'd be confused. So let's make sure we answer the question. Find the horizontal distance when the soccer ball is at a height. Then my answer would be the soccer ball is at 2.6 meters height twice, once 3 meters of horizontal travel, and once after 7 meters of horizontal travel. So I would hope you guys could maybe make that a better sentence. I just didn't want to take up too much time. But you do know that in a word problem, you respond with words. So the soccer ball is at 2.6 meters height twice, once 3 meters of horizontal travel, and once after 7 meters of horizontal travel. Okay, so I think that's enough video. And that was only one question. So I'll post another video in a second of the next question from page 300.